Welcome to Study Loop.
This is the answer to Chapter 21, problem number 75 from the Smith Organic Chemistry textbook. This problem asks us to draw a stepwise mechanism for this reaction that we're told is a key reaction in the synthesis of a drug. Okay, so the first thing that's going to happen is protonation of one of these oxygens. So this oxygen is protonated now. It only has one lone pair, and it has a positive charge. And so that is going to make it favorable for this carbon-oxygen bond to break and those electrons to revert to this oxygen. And so once that happens, we will be here. So we now have a carbocation. And so that carbocation is what the nitrogen nucleophile from the other piece of this molecule is going to attack. And so all right. And so the lone pair on the nitrogen is going to attack that positive charge. And that is going to get us to this intermediate. And I'm going to flip the orientation around. Okay. And so, of course, we'll still have our two hydrogens on the nitrogen. And so the nitrogen is going to have a positive charge. And the next step, we're going to use the chloride ion that we formed in our first step from the dissolution of the HCl bond. So this chloride ion is going to deprotonate the nitrogen. And so after that, we will have this intermediate. So we're back to having a lone pair on our nitrogen now and no charge. And the next thing that's going to happen is going to be protonation of the ether oxygen that we have. And so, again, we'll use HCl for that. Okay, so that's going to look like that. Okay, so now we have this oxygen protonated. So it's only going to have one lone pair. It's going to have a positive charge on it. So let's put that positive charge on this side. Okay, our nitrogen is still going to have a hydrogen on it that I omitted right there. Okay, so there we go. All right, and so the next thing that's going to happen is the lone pair on our nitrogen is going to attack the carbon to which it's already attached as the carbon-oxygen bond breaks. And again, this will be favorable because that oxygen is protonated. Okay, so our nitrogen is back to having a positive charge on it. And so the next thing that's going to happen is one of the double bonds in our ring is going to attack the carbon, and this is going to form our second ring. So the electrons are going to move like this. And so now, after this, we will be here. Okay, so there's our 5-membered ring. Here is our intact double bond. Hydrogen here we need to show. And we will have a carbocation right there at that carbon. And so the last thing that's going to happen to get us to our final product here, we're going to use a chloride ion again. And I forgot to include the negative charge on our first chloride ion. So there we go, negative charge. So that's going to grab this proton. The electrons from that carbon-hydrogen bond are going to go here. And so we formed a second double bond. And so that is going to get us to our final product, which is going to look like this. So double bond here and here. Let me not forget the hydrogen on the nitrogen. Okay, and so there we go. There is our final product of this reaction. And again, here's the stepwise mechanism for the formation of that product. And that's the answer to chapter 21, problem number 75.